Bismillahirrahmanirrahim. In the last part, we spoke about the scalar field, and we gave the value of the gradient of scalar field. We compute the gradient at some point, and we spoke about the directional derivative and maximum and minimum value of the directional derivative. In this part, we are going to speak about the vector field, in which that we are going to find the curl and divergence of the vector field. So let's start with the curl, which is just measuring the sometimes rotation of the fluid, or just feature of describing the fluid. For the curl of a vector field, let's start with the definition. A field F given by, or just a vector, let's say, given by Pi plus Q J plus R K, where P, Q, and R are functions of x, y, z. These are functions. Now the curl of this vector is given by curl F is equal to nabla cross F. This vector product or cross product, which is equal to I, J, and K, partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z of these three components, B, Q, and R, which is equal to R sub y. This, if we just compute it, it will be R sub y minus Q sub z I plus P sub z minus R sub x, the partial derivative. These are the partial derivatives. A plus Qx minus By. Okay. So this is the curl of a vector function. We have to keep in mind the curl is a vector. Because we have another thing that we are going to speak about it later on, that will be the divergence. Divergence is scalar field or scalar value. Let's take some examples. Find the curl of the given vector. Functions. Number one, so that f of x, y, z is equal to, let's say, xy e to power z I plus x to the power 3 y z j plus xy square. Okay. To find the curl of this vector function. So curl f is given by now black cross multiplication of f is equal to I j k partial with respect to x, partial derivative with respect to y, and partial derivative with respect to z. Whatever the component of the function, which is xy e to power z, x to power 3 y z, and last one is xy squared. So the first one is p, second one is q, third one is r. So I can use this one, or I will just use the direct formula for that one, which is given by r y or r sub y minus q sub z, and the others, partial derivatives. So the curl for this function is equal to use that formula, which is that will be r, or partial derivative of r with respect to z to y minus partial derivative with respect to z I plus partial derivative of b or p with respect to z minus the partial derivative of r with respect to x j plus q sub x minus b sub y k. Either using the determinant or use the directed one. Now the partial derivative of r, which is this is r, q and p. Differentiate r with respect to y. That will mean if we differentiate with respect to y, it means that keeping x as constant. So this is 2yx minus q sub z, so differentiate the second one with respect to z, that will give me x to power 3y. This is the first one. This is I. Plus p sub z, differentiate the first one with respect to z, just to differentiate the exponential function. And the others are constant, so it is e to power z. Minus r sub x, differentiate r with respect to x, I will have y squared. Plus, and differentiate q with respect to x, I will have 3x y z minus p sub y, that will be x e to power z k. So this is the curl for this function. Can we find the curl of the given vector function? Let's take another one. Number 2. Take for example, that's y equal or f equal to x, y, z is given by x minus y to power 3 I plus e to power minus yz j plus x y e to power 2y. Find the curve for this one. Equal to r sub y minus q sub z. This is p, this is q, this is r. So differentiate r with respect to y. For the derivative of r with respect to y, we have to apply the product rule because I have y there multiplied by e to power 2y. So it will be x multiplied by, differentiate with respect to y, it is f prime g plus g prime f, applying the product rule, by the product rule. Or let me write them one by one down, just to make it clear. I have p of x, y, z is equal to the first one, which is x minus y to power 3. For this one, I need to find bz and py. For the first function, no need to differentiate with respect to x. So b sub y equal to 3 multiplied by x minus y to power 2 multiplied by the derivative of what is inside, that will be minus 1. So it is minus 3. This is by the chain rule. X minus y to power 2. B sub z, there is no z, so this is equal to 0. Second one, q. It is equal to, the second one, it is e to power minus yz. For q, we need to find the derivative with respect to x and z. Q sub x equal to 0 because there is no x in this function. Q sub z equal to this exponential function. I will have minus y e to power minus yz. Third one, r. R of x, y, z equal to the third one, which is x, y, e to power 2, y. Now for this one, I need to find r sub y and r sub x. So the partial derivative with respect, let's start with x first, equal to y e to power 2 y. Now r sub y, or the partial derivative with respect to y, is given by, it is x multiplied by the product rule. To find the derivative for this one, we have to apply the product rule. The product rule is f prime g plus g prime f. The derivative of the first function, which is y in this case, is 1 times e to power 2y plus. Now derivative of the power is 2. Keeping the first function, y e to power 2y. This is r sub y. Or I can write it as x e to power 2y plus 2x y e to power 2y. Now I have all of these partial derivatives. We can write the curve of the function. Curve of f equal to, I use the determinant or use the formula there, this one. R sub y minus q sub z. Write it first. R sub y minus q sub x I plus b sub z, partial derivative of p with respect to z minus r sub x j plus q sub x minus p sub y. Okay, this is equal to r sub y is equal to x e to power 2y plus 2x y e to power 2y minus q sub x is equal to 0. This is the first one. Plus p sub z, p sub z equal to 0. Minus r sub x, which is y, e to power 2y. This is the second part, or second component, plus, now q sub x, it should be q sub, no, the first one is q sub z, not x, this is z. This is a q sub z. I made mistake in this one. Let me move this one. Q sub z is given by minus, so it should be plus y e to power minus yz. This is the first one. Second component is p sub z minus r sub x. P sub z is equal to 0 minus r sub x, which is y e to power 2y j. Last one, q sub x minus p sub y. Q sub x equal to 0 minus p sub y, which is this one, it will be minus with minus will be plus, so this will be plus 3x minus y to power 2k. So this is the curve for this function. R sub y minus q sub z I plus p sub z minus r sub x j plus q sub x minus p sub y k. One more. F is given by, not in this notation now, 4xy 2 x to power 2 plus 2yz, and the third component is 3 z square plus y square. And we need to find the curve equal to r sub y minus q sub z I plus p sub z minus r sub x j plus q sub x minus p sub y k. Now differentiate r with respect to y. This is p, this is q, and the last one is r. So with respect to y, it is 2y minus q sub z. Differentiate the second one with respect to z, it is 2y. Next one, p sub z. Differentiate the first one with respect to z is equal to 0. And r sub x is 0. This is j. Third one, q sub x is 4 x p sub y for y. And this is 0 I 0 j 0 k, or simply it is just 0 vector. So if now I have the curl of the vector function is 0. If the curl is equal to 0 everywhere, or you can say that if the curl of a vector field is equal to 0 everywhere, we say that the vector field is irrotational. Now this is the curl of a vector field is equal to 0 everywhere, then the vector field is said to be irrotational. So the vector field is irrotational if the curl is equal to 0. If the dot product of the nabla with the vector field is equal to 0, then we call that fluid is incompressible. And if we speak about it in the magnetic field or electromagnetic, so we say that it is solenoidal if the nabla dot equal to 0 equal to, or nabla delta f equal to 0. We say this is 1. Number 2, if equal to 0, then the fluid is called incompressible. Or done. This is in the electromagnetic field. So if the curl is equal to 0, we call this irrotational vector field. If the dot product lambda dot f equal to 0, it is incompressible or solenoidal vector field.